Alright guys, I'm Dave and what we have here is a rock paper scissors console game. Yeah, it doesn't look as colorful and exciting as the Unreal games, but it's way cooler, and here's why. This game is made from scratch. And you see, when you make it something from scratch in C++, you should apply the best practices of object-oriented design. And the most common practices of object-oriented design are called design patterns. It's good to know that design patterns are just general solutions to general problems, and their concrete realization may vary from case to case. So, in this video I'll tell you how my rock paper scissors stands out, and we'll talk about design patterns along the way. This rock paper scissors game has two variants of game rules, classical and from the Big Bang Theory TV series, three variants of multi-person tournament, each versus each, grid and mass, a configurable number of rounds to determine a winner, and the ability to play with bots. By the way, this repository is public and you can open it on your computer for more exploration, so check the description. And the first thing we should get our attention on here is the variants of the game rules. And this is where our strategy pattern comes in. The strategy pattern is basically having different ways to do something. These ways are stored in different classes and are called strategies accordingly. The key feature here is that they should be completely interchangeable and you should be able to switch between them effortlessly. To achieve that, there must be a common interface or a base class. Here is my base class for the game rules as an example. The main thing here is the determine winner method. So we have different strategies of how to determine a winner defined in our derived classes. This is a pure virtual member function, so every derived class must have it defined. This is how it is defined in Classic Game Rules class and in Big Bang Game Rules class. You can also see that their own array of possible moves is initialized during construction. I can define different movesets with, for example, UFO, cat and whatever, and determine which one beats which one. The main point here is that I can make as many varieties of rules as I want, and they will all be interchangeable, so I can easily pick which one to play with, and these all will be different strategies. Alright, so when you launch the game manager class collects all the necessary data to create a tournament for you, such as type of rules, amount of players, type of preferred tournament, and amount of wins needed to determine a winner. But the game manager doesn't know and actually shouldn't know about tournament classes, their differences and how to create one, so he passes all the collected information to the tournament factory. The primary purpose of the factory pattern is to create objects without specifying their concrete classes. It adds a layer of abstraction, making it easy to generate objects of different types based on certain parameters. In the game, the tournament factory dynamically takes all the information during runtime and creates a specific tournament. You can see that Game Manager does not include any of the tournament headers, so he knows nothing about these classes. The only thing he should know is what data he needs to pass to the factory so it can create a tournament class. Let's take a closer look to my factory implementation. It has only one static method, so this factory does not have to have an instance to run. The void return type may look weird to you, but it's because this factory creates two objects and places them on the addresses of these out parameters that you should pass to it. One for the tournament class itself and one for the tournament UI class, which we will talk about in a moment. Of course, the factory doesn't have to be like this. Let's take a look at the rules factory. It just takes a rule type as a parameter and returns a unique pointer to create its rules object. And speaking of the tournament UI class. UI classes in this game are separated from the logic classes and are responsible for displaying messages on a screen and also clearing and refreshing it. It's done for two reasons. First is the S letter in solid principles of object-oriented design. It's called a single responsibility principle, and it states that a class should have one and only one reason to change, meaning that a class should have only one job. And the second reason is a potential ability to switch from a command line interface to some sort of a graphical interface without rewriting the whole tournament code. What does it mean? That the tournament logic is living its own independent life without knowing what users see on the screen. And it doesn't matter, it cares only about what moves users made, who is the winner and who will face whom according to the tournament rules. But the tournament UI class is always watching what is happening in the tournament class and reacts on certain events by displaying messages. It's the observer of a tournament class. Usually, the observer design pattern implies a way to notify several objects, called observers, about accomplishment of some event in an observed class, called subject. There are many ways to do it in C++ depending on a specific case, but usually it's an array of function pointers in a subject class, and all the observers put their methods in there. And when some event happens, the subject class goes through that array and all of those methods are called. In my case, I have only one observer, it's the tournament UI. It puts his method into the single std function, so that the method can be called when something happens, thereby alerting the observing class. When an object leaves its method there, it's like when you leave your email address when subscribing to something. You say like, hey, notify me by this address when something happens. And to tell him exactly what happened, I did the event enum class. So when something happens, my tournament calls the event callback function and passes the event enum there. It doesn't know whose method is in that callback, it just calls it, passing the event like player made move, round ended, and so on. And the tournament UI class responds like, player made move, so I should clear the screen, or all players made their moves, so I should display which player made which move and who won. And that's pretty much all I wanted to say. Of course, for better understanding of design patterns, you should study our dedicated materials. At least you should definitely check the Refactoring Guru site if you haven't so, and to understand exactly how things are done in my code, don't hesitate to check it out in my repository.